Okay, so I'm going to show you how to work through problem number 8 in the Circuits 2 exam review. A 20-volt battery, so that means that this is the total. So I'm just going to write down what we've already know just based on what the problem says. Is connected across a series resistors and 2 resistors in parallel. The current through the 12 ohm resistor is 1.2 amps. So here's a 12 ohm resistor. It's going to be 1.2 amps. So I'll just write that here, 1.2 amps. And we see this resistor 1 is in series and these are in parallel. So that means that whatever the total current is for this one will also be the current, so 3A. These two need to add up to 3A. So using my calculating methods, we have 3 minus 1.2 is 1.8A. With this, now I am able to figure out voltage drops, which, let's see, 8 times 1.8 is 14.4, and 12 times 1.2 is 14.4, which is good because they should be the same. Next, I have these, the voltage drop here, or the voltage here, should add up to 20. So 20 minus 14.4 is going to be 5.6 volts. Now we can find out the resistance. So 5.6 divided by 3 going to be 1.87 ohms. 20 divided by 3 is going to be 6.7 ohms. And power is just going to be current times voltage. So we have 3 times 20, which is 60 watts. 3 times 5.6 is going to be 16.8 watts. 1.8 times 14.4 is 25.9 watts. 14.4 times 1.2 is 17.3 watts. And we're not going to look at the total brightness right now. We're just going to look at the individual ones. So this is the first brightest, the second, and the third brightest. Now the schematic, we're going to draw battery, voltage circle, ammeter, voltage circle, resistor, circle, voltage circle, voltage circle. Wire, voltage circles, resistor, voltage circle, resistor, voltage circle. And we have an ammeter here, voltage circles, circle, circle, ammeter, circle, voltage circle, and a wire. And so the total that we have here should be the total here. And this resistor has a 5.6 drop. So it's 20 here, 20, 20, and then it has a 5.6 drop, which gives us 14.4. So this is going to be 14.4. And at the end, because I know that whatever I start with, I need to end up with 0. So based on this, we have 1.2, 1.8, so 14.4 here, and 0. All right, and then voltage graph really quickly. I'll do this A, B, C, D, E, F, and then I'll call this G. I'll call this H. So A, B, C, D, E, F, G, H. I start at 0 and I end at 0, then I go up to 20, then I stay at 20 for C. At D, I go to 14.4. I stay at 14.4 for E, and then I go down, oh, I stay at 14.4 for F, and I go down to 0 for G. So for one of the branch pathways, this is what it might look like. For the other one, I just might look like this. Okay. And that's how you would go through that problem. Thanks for watching.